for his talk. So please welcome Doug to the stage.
And can you guys hear me? Do we have, all right, we've got that, and it sounds like everything's working, so that's good. Thanks, Perry, for the introduction. As you mentioned, I'm Doug Sillars. I'm originally from Seattle, Washington, but I'm traveling with my family through Europe, and we're spending the summer in Dublin. So my wife said, hey, let's go to the UK and to London for a week. And I said, well, I've been talking to Perry about August. So we managed our trip here this week, which has been awesome, except for the heat, of course, but we're surviving. So real quickly, a little bit about me. I was here about 2.5 years ago, maybe, and I talked about mobile app performance. I'm currently freelancing. I do performance audits, web, native. I do workshops. I'm a Google developer expert now. That was kind of cool. And then if you ever need to get a hold of me, there are no other Doug Sillars on the internet. So like everything's Doug Sillars. But I'm here to talk a little bit about video and how video is delivered on the web quickly, beautifully, and without stalls. As we probably all know, video is growing like crazy. They're saying, 67% of the internet, or 67% is just going to be internet video, and then streaming and other stuff on top of it. Like video is something that's huge and is growing. If we look at the HTTP archive, which is just looking at the landing page of 500,000 websites, we can see that it's grown about 0.5% year over year, June to June. And I used the June data because they just changed the number of websites. So I want to make sure that the numbers are the same. But we see there's a little bit more on desktop than there is on mobile, but we do see growth of video streaming on the web. And I was looking into what video quality metrics are and what people consider to be good video quality metrics. And the first one is, did the video start playing? And that's an important metric. And then the second one is, did the video stall? And then the third one is, did the video look good? And these are kind of really important sort of basic metrics. And what I want to say is that if we look at optimizing the delivery of video, we can solve some of these issues, right? If you're having these issues with your website, we can do that by just optimizing the delivery of the content. So how bad is video startup? And so this is Conviva. They're a video analytics provider. This is Q1 of this year. They found that 2% of all videos, somebody pressed play and they didn't start. The video just didn't play. That's the little red segment of the pie. They found 11.5%, they pressed play and then they gave up before the video started. And so that's 400 million in the red, 2 billion abandoned in the yellow, right? That's 2.4 billion views, or about 800 million hours of video playback that was lost on the web just at startup. And so what's causing the red? And I'm not really sure, but I think it's probably stuff like this, right? Oops, we can't play it in your country. So like when I'm on Amazon and I try to watch something on Amazon Prime from America, it tells me right up advanced, like, hey, you're in Europe, we've got a lot of great TV that you can't watch. And then they list it all, but they show like, you can't watch it, you can't watch it. So I don't like waste my time clicking and trying to get through to get to this level. And when you start looking at that, you're like, well, that's not so horrible, until you look at the dev tools and you see that it took 3.1 megabytes. And it wasn't 18 seconds. I just wasn't fast enough with my screen capture. But because there's some sort of like tracking beacon making sure that I'm not watching the thing that I can't watch. So that's why it refreshed it at 19 seconds there. But there are a lot of ways that you can just prevent people from seeing that. And you're obviously going to remove the disappointment of people who are viewing things on the web. But probably more importantly, like what's happening with this 11.5% of viewers that just give up? And so this same study gave the average video start time. And they say in Europe, the average video start time is 4.3 seconds. But like an average for all users, mobile, desktop, 2G, 3G, 4G, fiber, right? Like that average is like, there's a lot of data underneath there. There's a long tail there probably. So averages aren't very good there. But 4 seconds for a start time, that could be pretty long, and it's almost 5 seconds in North America. So this is a few years old, but Akamai did a study, and they were looking at how quickly people abandon how long people will wait for a video to start playing after they press start. And basically, everybody gets 2 seconds. 100% of people will wait 2 seconds for a video to start, but every additional second afterwards, you lose almost 6% of your viewers. And so if you want people to watch your video, you need it to start up pretty quickly. They found there's a bit of a dichotomy in the types of videos. So if it's a short play video, like a cat in a shark costume on a Roomba chasing a duck, after about 3 seconds, people start questioning their life choices, and they abandon that more quickly. So that's the blue line. And then if it's a long, you're going to watch a movie for an hour or something, you're going to hang out. You're willing to hang out for 10, 15 seconds because that's the sort of thing that, you're already spending a lot of time. You're willing to wait that long. But let's look back at the HTTP archive, and this is now July data, where they're now running 1.2 million websites every 2 weeks on mobile and desktop. So we're looking at a lot more websites than we ever have before with the HTTP archive. They're running web page tests, but we can look at how many sites have video of those 1.2 million websites. And this is actually downloading video files, not like there's a video that you can press play and then it'll download it. And there are 36,000 on mobile and 55,000 on desktop. And we can look to see, where they overlap, and 30,000, have it both on the mobile and on the desktop website. And that's 83% of all the mobile sites. So there's a segment of the mobile sites that don't have it on the desktop. I have to go further in to see exactly what's going on there. But we'll focus on the ones where the mobile and the desktop sites both have video, because that's something that's really interesting. We can compare how websites are serving video to the desktop versus how they're serving it to the mobile, and are we doing that efficiently? And so what we see is in that middle circle of the Venn diagram, we've got 207,000 on the desktop, 185,000 video requests on mobile. 21,000 of that 30,000 use the identical video on desktop and mobile. So they're serving the same content to that tiny little device in your pocket than they are to this giant laptop that's probably connected to a fast network connection. And 41,000 of that 185,000 are actually identical. And so the way web page test and the HTTP archive work is they're not running these tests at the same time. So if you're testing a web page, the mobile test and the desktop test may be days apart. So if it's a news site, those videos are going to be different because obviously the news has changed. So these are probably static sites where it's 19% of all the videos on mobile are identical to the ones that are being served on the desktop. And if you start thinking about delivery of files, there's probably a big problem here that we can look to optimize. And the big problem is, if it's a big file that's set up to run really well on a desktop, it may look really, really bad on mobile. So the video might not actually start on mobile. Or if you have it optimized to look good on mobile, it may not look good on the desktop because it's probably a larger screen. So what are we going to do to optimize video? And I'm going to go back to sort of image optimization, because what are images but what are videos but just like a series of images? So let's start with image optimization and images. So let's start with image optimization, and Perry asked for goats, so I made sure that I had some goats. We used to have goats when we were out in Seattle. It wouldn't be goats if this is Josephine. She was one of our goats. What you can do with these images is you can optimize them. So we can do image quality, we can do change the format, we can do responsive images, and let's just walk through this really, really quickly. So if you have a 2.5 megabyte start image, and I did this with Cloudinary, and so with Cloudinary you can just put the parameters in the URL and it generates the image for you. I set it to the quality where you can't tell a difference, which is auto or structural similarity, and I got it down to 1.2 megabytes. I changed the format to WebP. I got it, I saved another, 40 kilobytes. And then I said, well, let's make it 1400 pixels wide, and I saved another megabyte, right? So there's huge optimizations that people do on images, and obviously you can make them a lot smaller, and we can do the same thing with video, but let's see what people are actually doing. Well, let's first look at what people are doing with image optimization. So if we look at all of the web pages in the HTTP archive, and this is again the half 500,000, this is from June. If we look at the percentiles, we can see that mobile images in general use less data than desktop. You can see that the y-axis is megabytes of data. It's usually running about 10% less on mobile. We could probably do a lot better than that, but we're less. Let's look at video. Well, the one thing to look at video now is the y-axis has gone up by a factor of 10, right? We're now looking at 70 megabytes. And if you look out here at the long tail out past the 70th percentile, we actually have the mobile sites are using more data than desktop sites in terms of the kilobytes and megabytes of video being sent over the network, right? So we've got a problem here. We can do a ratio, and we see that this blue is the image differential, and we're always below 1. I don't know if you can see that there is a line there showing that it's below 1. It's usually about 90%. But as you can see, video, we're using a lot more. There's more. If you do mobile over desktop, we're at 1.2 at the 95th percentile, right? Where they're sending so much more video onto mobile sites than they are onto desktop sites, which is probably backwards from what we need to be doing. So let's talk a little bit about video and what you can do to optimize. So we talk about images. You have one image. This is Nora. So, and Alden in the back. But when you talk about video, you have a series of images, right? And then on top of that, instead of just images that you have to optimize, you have audio that you have to worry about too. So what do we do? The great thing about video is that it's broken up into, this is the most technical slide I have here, but it's broken into a group of pictures. Eyes are the full frame image. The P's are the P frames, and so they're forward predicted based on eye. And so they use 50% of the size of an iframe. And then in between, there are these B frames that they predict between the I's and the P's, and they're 25%. And so each frame, you can see in the middle, are going to be a lot smaller, and that's how we do the compression in video, is that all the B's and P's are a lot smaller than the I's, and that's where we get video compression through the third dimension of time, right? We have X and Y, and then we have the dimension of time, which is our third dimension. And so here's this video. And these are the P frames. And so what the arrows are showing are the vectors where they're finding the colors and things to match. And so this is how we're doing the optimization and the compression. And then you can see the B frames, that's this one. And then you can combine it, and you can get the P and the B frames. And so you can see there's a lot of things that are being reused and can be compressed to create just a simple video. And this compression is where we get a lot of savings when we talk about video that's being delivered on the web. So the video I took of Nora eating that cedar leaf is 1.4 megabytes. I took it on my phone. And let's talk about animated GIFs, because that's sort of like a segue into how we deal with video. And if I create this into an animated GIF, it's 256 colors, and it's awesome, and it's 1980s technology. But because the way animated GIFs work is they don't have the group of pictures, they don't do the compression in between, it actually got bigger. It's 270% bigger because there's no compression in between on the intermediate frames. They're all full images. It's just like a flip book of images. So, turning it into a movie with 256 colors, stripping out the audio track, you can make it a lot smaller, right? I took it down from 3.8 megabytes to 250 kilobytes. And I can take that animated GIF and serve it up as video on my website, and then it'll be a lot smaller. So if you set it to loop autoplay muted, and then you play the goat, it will loop on the web page. You have to say muted on mobile, on both Chrome and Safari, for it to autoplay, and that's because when you're in a meeting and you're browsing on the web, you don't want the videos to be really loud, because then you're busted. The problem is, of course, browsers know that videos are really large. Videos are the biggest file that'll probably be on your web page. Hopefully they're the largest file that'll be on your web page. So they're the last thing to be downloaded. And but what's really cool in Safari right now is you can actually put MP4 videos inside the picture tag and it will load them. And so there's a performance advent calendar article about this last year, but it's now in Safari. So if you're on an iPhone or on a Mac or running Safari, you can actually loop a MP4 inside the picture tag. So on the Apple products, it's going to download 250 kilobytes versus 3 megabytes for the animated GIF. But let's talk a little bit about the different video file extensions that I see on the web. It's mostly MP4s. There's a little bit of streaming with the TS files, but let's focus most on what people are doing and serving in terms of video on the web today. And so, as I said earlier, at least 19% of all videos are identical on mobile and desktop. And so this is a baseball website in America, the desktop there. This video right here is the same video there. And if you look, it is 17 megabytes, right? So you're downloading the 17 megabyte video to both desktop and to mobile. And you start looking at it, it's reasonable dimensions, 960 by 540, is 83 seconds, 1.78 megabits per second. And there are a couple different tools that we can look at here to optimize this. If I downscale this to 1.37 megabits per second, you can do this with FFmpeg. I did it with, again, with Cloudnear. I just set the video quality to auto. The quality set to 70, the audio is downgraded to 22 kilobits. And I get it down to 13.3 megabyte file, right? So that's going to download a lot faster on a mobile. Maybe even you just serve that to the mobile device. Maybe even you just serve that to the mobile device, the lower quality, slightly lower quality video, just to get it downloaded faster. If you wanted to go to a smaller dimension, right, you could have a 640 by 360 for mobile, and it's 62% smaller. That's going to obviously download a lot faster and look a lot, you probably won't even notice a difference on a mobile phone when it's scrunched down in portrait mode as part of a web page. So I mentioned earlier that a lot of websites are actually downloading more content on mobile than they are on desktop. And here's an example of a site that on desktop it's downloading 257K, and on mobile it's double that. It's over 500 kilobytes, 566 kilobytes. And actually what they're doing is they're downloading Retina versions of these little 4-second video looping tutorial things about how their product is so awesome. And they're looping these Retina things onto the Moto G4 that they use for web page test. And so you can see that, yeah, if it's Retina, we're going to serve the Retina one. But to make things worse, they hide it if the width is under 1024 pixels. So they're downloading these videos that are twice as large, then it doesn't actually show up on the screen. So remember display none with responsive images, and everybody was hiding the images, but they were still downloading. We're doing it yet again with videos, right? We're downloading these giant files and slowing down the loading of the web page, and they don't actually ever show up on the screen. Another thing to look at, this is a web page that I loaded, and this is web page test, and you can see the waterfall here. They had a video that they set preload equals auto. And when you set preload equals auto, basically the browser says, all right, I'm going to download that whole thing. No matter what, preload equals auto means that whole video is downloaded. So it's like that at the end of the waterfall, right? The teal are video downloads. And it ends up actually being, what is that, 23.5 megabytes of video that were downloaded because I set this. This is just a landing page of a web page. At the bottom, there's a video, whether you press play or not. It's up to you, but no matter what, on your mobile phone, you're getting 23 megabytes of data. And on mobile, people are on limited data plans. People are on slow network connections. This is not super friendly to your mobile customers. So you should really only use preload equals auto if you know they're going to watch it, right? If it's like, click here to watch our video, that might be the place to do preload equals auto, but otherwise maybe not. The next one that you can use is preload equals metadata. And so that only downloads the first X% of the video. And so you can see here, it's the line right there. You know, the big teal line is downloading the first X% of the video. And you can see that there's one video request. The teal line is right there at 12 o'clock in the pie chart. But it ends up actually being 2.7 megabytes of data. And so that's kind of a huge, even though it's the metadata, that's kind of huge. And the reason it's so big is that the full video is actually, it's 1920 by 1080. It's 2.5 minutes long, and it's 97 megabytes. So the first little bit of it is actually 2.7 megabytes. And so that's kind of painful when you start thinking about your mobile customer. So let's look at the web page on mobile where that's downloaded. So that's the first 7 viewports. Here's the there's the 14 viewports. The video's right there. So you have to scroll for just about ever to find the video at the bottom of the page that's downloading 42% of the payload of the web page. So preload equals metadata is really, really great, but you should use it with discretion. Like, what are the odds that someone's going to scroll all the way down on the mobile site to click that video to press play? This one is probably one that likely does not need that, and you could save 2.7 megabytes on each load. So, you know, my best practice there is avoid preload equals auto unless you really know they're going to watch it. And your mileage may vary with the metadata. Like in general, I would say use metadata. You get that first little bit of the video downloaded so it's ready to play as soon as they press play. But in the example I just showed you there, it's probably not the best thing to do. Odds of somebody actually scrolling 20 viewports to actually see that video is really, really, really low. My other pet peeve when it comes to video is the video backgrounds. We've all seen them, right? The background that's playing on the web page in the background. And so there's this web page here that I found using the HTTP archive, and it's got this video, and it has audio. And I don't know if I have my audio turned on. Let's see how I got my audio turned on. And we don't have it plugged in. Oh, maybe it'll go through the HDMI. Who knows? It says it's going to go through the HDMI. But let's see here. It's not playing. All right. But anyway, this is the video that's playing in the background. And if we had audio, you'd hear that there's a voiceover. And it starts mid-sentence and it ends mid-sentence. And I was like, well, why is this thing, you know, what's the editing here that it's going on in mid-sentence? And we can actually look, we can run FFProbe, which is part of FFmpeg, and it tells you, you know, how many streams there are. There's 2 streams. The file, you can see the file name, you can see it's 15 seconds, you can see the size, you can see the bit rate, all of that information. And we can also get the information on the different streams. So we've got stream 1, you know, it's H264, you know, all this information about the video. It's, what is it, 1280 by 720. And we can also see that there's an audio stream. And the problem with this, of course, is that we're sending 44K audio for a video that's completely silent on the browser. And so when we look at it, it's 5% of the file is just downloaded every single time, but never used by the end user. So if you're going to send a silent video, remove the audio. Pretty straightforward. You're going to obviously make those files a lot smaller, and it will download a lot faster. Again, when I do it on mobile, you can still see the teal at the end of the video download, but they block at a certain viewport, it disappears. So they download the entire video, but it doesn't appear on mobile. So make sure that if your viewport isn't going to support it, don't download it, because you're just killing people's data plans with downloading extra video. This is a great one. This is another website. It's got a background video of this lady right here. It starts off, you thought Bob Ross just did art, but he's a photographer too. So this is the video. I'm not going to press play yet, but it's 33.6 megabytes for a background video, right? I hope you're all cringing already. Are we cringing yet? All right. It's 27 seconds long. It's 2,500 pixels by 1,200 pixels, right? And it's 10 megabits per second, right? It takes forever for it to start on my desktop, right? So resize it, right? Very few people are gonna wait for a 33 megabyte background video to load. And I think they tried to. If you look at the name of the file, but naming the file just isn't quite enough, right? It's new, it is new, but they didn't actually re-encode it to 720 pixels wide, which would actually load a lot faster. In fact, it goes down to 1.7 megabytes, right? It's way, way, way smaller. If you do this on mobile, guess what? It downloads on mobile, even though it doesn't play on mobile. And so now finally, I think this is time to watch the movie. And it is silent. And so you see this lady walking through the park, and she sees the child, and the child comes up and runs, or whatever. But what's interesting is right about here, it starts over again. Yeah, they have the same video, 15 seconds, downloaded twice, so the video is 27 seconds long. Obviously, if you can only download it once, if you don't duplicate the loop in download, the browser's really good at looping it for you on your own. So they could have cut that down by half pretty easily. And then the last one, this is one that actually plays the video on mobile, but it's 1920 by 1080. It's 30 megabytes. It's the same video, mobile and desktop. And as I've been looking at waterfalls like this, I've come to dub this approach as the mobile middle finger. Like, how much do you care about your mobile customers? There it is, right? You're downloading a 30 megabyte video to play in the background. So, so far, we've seen one that sends down, a 2x size video. So be careful on mobile. If you're going to hide the video, don't download it, resize it so it shows up. Try to avoid the preload equals auto. Be careful with preload equals metadata. If you're going to have a silent movie, strip out the audio track. Don't duplicate the traffic. And, it really comes down to mobile users are not all going to be on 4G, really fast downtown London connections. I just spent a month in West Cork, Ireland, and I was on edge almost for an entire month, and it was really eye-opening. Our Airbnb had Wi-Fi, but it was connected to a 3G router, so I really was on edge for an entire month, and these websites just wouldn't have worked at all. So really, it's important to just respect your mobile users' data plans. I'm going to jump a little bit into streaming. As you can see here, about, 8% of all the files that we saw in the HTTP archive are TS files, which is HLS streaming files. And just a little background of how streaming works. The first thing that gets downloaded is a manifest file. And this manifest file tells the player what sort of streams are available and what can be played. And the player chooses a stream from that list. It starts downloading the segments, and it will hopefully start playing, right? The buffer fills up, and the video starts playing. After the video starts playing, the player can estimate the network throughput and decide if it needs to go to a lower quality version of the video or a higher quality version of the video. And it will change the bit rate depending on what it finds. And because we're testing with the HTTP archive, remember that mobile is always set to 1.6 megabits per second, and desktop is set, the bit rate is set to 5 megabits per second. And so that's important to think about as we start looking at streaming, because we assume that the first segment's going to download and then it's going to switch depending if the web page test run was done on mobile or if it was run on desktop. And so this is what a manifest file looks like. This is for a TED Talk, just a TED Talk I found on one of the pages. And so you get video tracks. These are the video tracks if it's in an iframe. And these are audio tracks. And for a TED Talk, there's only one audio track, and then they have subtitles in like 15 different languages. So you can select the different language. And this one's interesting because the first one listed is Greek, and then it's English, and then it's something else. So the first choice is, and it's in Japanese. So the first subtitle is in Greek, so you can watch it in Japanese and listen to it in Greek, and then whatever. But this is what the video tracks. And so there's a bunch of information here. You can see, play the audio track. This is the bandwidth. You can see the codecs. You can see the resolution. And then this is the URL to where to get the more information about all of those tracks. And you can see there's, I don't know, 6 or 7 different bit rates that are available for this one file. So if we go back, we can see of all of the identical files that are here, there are about 2,000 TS files that are identical. And to me, that sort of is approximation of that first query. It's going to be the same download, whether it's on desktop or mobile. And so I'm approximating the first stream choice by these 1,900 files. And what we see for the initial bit rate is, for the most part, the initial bit rate is below 1 megabit per second. About 86% of them are below 1 megabit percent of them are below 1 megabit per second. There are a few out there at 3 megabits per second. You can see there's a jump out there. We can imagine that on mobile, those are going to jump down to a much lower bit rate, because that's not going to be able to stream with the bit rate of it, with the throughput available with the HTTP archive runs. And so what we see is the initial percentage is in green here, and mobile is in yellow. And so you can see most of the mobile is actually between under 400,000 kilobits per second. There are a few, you can see they start up in this bump here. They start there, but there's less overall there. They tend to go to a lower bit rate. And interesting, the same thing happens for desktop. There's a lot, 10% are at the very lowest bucket there, 30% are in the second lowest bucket. And then there are a few out here. You can see there are a couple further bumps out here as we go further out, because some of them actually do go out to a better quality video. That's all of them on one slide, but I had a really hard time explaining that when I was practicing. So what's happening here is, what happens if the player selects as a really high bitrate stream? The buffer takes a long time to fill, and the video doesn't play. And so then the player's like, oh my goodness, I've got to choose a lower bit rate. The buffer starts to fill, and the video plays. So why we're seeing a bunch of videos down at the very far end of that graph is probably the videos weren't playing correctly at the very beginning. And obviously, if you think about the steps here, if this is taking a long time and then it has to take a different, this is video startup time. This is one of those key metrics that people are looking at. This is adding to delays of why people might be giving up on the video playback. I had that slide. All right, double slides. So when we look at the way the manifests are built, the way the manifest always, the player always chooses the first bit rate. In this case, it's on the left. So imagine you set all of your bit rates in order from low to high. The first bit rate that's going to be selected is a really low quality video, low bit rate, but it's going to start playing really, really quickly, because it's, you know, it's a very small number of bytes to get it downloaded till it can start playing. And then eventually, as the player realizes there's a higher bit rate, it'll pick a middle bit rate and stay there. And you've seen this when you're watching videos on your phone, or even like with Netflix, you'll notice that the first few seconds are really pixelated. And then about 3 seconds in, it snaps to a really, really nice high quality video. And that's what's happening. It's something like this. You can do the opposite. You can start at high, but it doesn't play right away. It switches to low quality, and then you end up in the middle. But that's adding one more step to the whole process. That's slowing down the video startup delivery. And then there's sort of the Goldilocks example, where it's not the highest and it's not the lowest, but you start right in the middle. And what happens there, it takes a little longer to start up, but you've got a nice quality to start with at the very beginning. Amazon Video does this because they know you're watching a half-hour TV show or an hour TV show or a 2-hour-long movie. You're willing to wait a little longer, and the quality is always really good when you start the video right away, because they're starting with a pretty good quality. We can look at this with web page test. So if I start with the lowest quality video, it starts playing the fastest right here at 11 seconds. It's low quality. It pops into a nicer quality out here at 16, 17 seconds. When I pick the middle quality, it's playing at 13, 14 seconds, and it's a good quality video. The high to low, this quality video here at 17 seconds is identical to the quality over there at 11 seconds. So you started with a high quality video, you want it to play, but on mobile, you might end up with a really low quality video that took a lot longer to start. And so that's obviously not ideal. So if you try to graph all of these, well, if you start with a high quality video on a really fast connection, it's going to be awesome. But if you're on a mobile connection, you're going to have a very slow startup and a very low initial quality. And that's obviously the opposite of everything that we're trying to do here. If you start with a low quality video, it's going to start up really fast, no matter what kind of network connection. The initial quality is going to be low, but after 2 or 3 seconds, it's going to pop up to a really nice quality. And then in the middle, you sort of have this initial quality is good, but it's sort of in between in terms of how fast the video starts up. So let's go back to the TED Talk that I was showing you earlier. There's 2 different streams here. The teal is the video, and then the gray is the audio, because the audio track is separated. This is really cool. This is a great advantage, because then you can, if you have different audio tracks, you can have an English, you can have a German, you can have a Spanish, and you can just have it, you can switch in between the different audio tracks, which is really awesome. But what I see is these are the different bit rates. It starts at like, I don't know, 1.4 megabits per second is the first bit rate that I see. And it drops to this, I don't know, 200 kilobit per second bit rate, and it sits there. It never gets better. For whatever reason, when I play this on mobile, it just sits at the lowest bit rate, and it never improves from it. So something's going on here. There's something weird with this video where they did something wrong, and it's not playing correctly, because we'd expect, we've got 3G, we should get to 1.6 megabits per second. One of these ones in the middle should play and be able to stream efficiently. But if we look at this a little more carefully, the first bit rate is 1.4 megabits per second bandwidth. But if we look at the URL is saying that it's 600 kilobits per second. So there's a mismatch here in the manifest, in the parameters that are being sent to the player. The player is reading the top number, not paying attention to what the actual is available. And if you look all the way down, 228 to 64, 587 to 80, they're almost 3x overestimating the bandwidth here. And that's actually causing a problem with the streaming of the video. So what happens if I go and I rewrite the manifest file, then it matches? Set the manifest at the beginning to 600K, because that's what the video actually is. The first thing that happens is my graph changes, because I'm not at 1.4 megabits per second. I'm at 600 kilobits per second for that first stream, right? I just lowered the bandwidth of all of these things just by fixing the manifest file. And what I see is, for some reason, it jumps down to the lowest bit rate at first, but it makes its way back up to the high quality bit rate pretty quickly within the first 10 seconds or so of the video. So it goes to the lowest one, and then eventually makes its way higher, and then stops at the 600 kilobit per second stream. And I was like, I'm still confused as to why it's dropping at the beginning. And so I looked at that stream, and this is actually kind of cool if you think about it. What they have here is this 1600K, it's the intro. And so they can rewrite the intro for every single one of their videos just by going through and replacing this with a different intro. If they ever wanted to change the intro for every single TED Talk, they could just replace those first 3 lines of the manifest file and change it. And what they've got wrong here is some of the timing with this is how long this segment should be. And they've screwed it all up. And so I was playing around with it, and I just finally said, well, to heck with it. Let's just say the whole intro is not 11.9 seconds long, and let's just show it and not screw around with byte ranges and see what happens. And when I load that on a mobile device, it plays at 600 kilobits per second, and it jumps up to 950 kilobits per second, and it streams. You don't see any of the pixelations. For some reason, there's just some weirdness in their manifest files, and it's actually degrading the video quality for all of their viewers on mobile devices. And so by going in and looking at it and auditing it, I was able to make this run a lot better. And it actually goes up to a higher bit rate as the video is playing. Now, I actually found this video on a website, and I don't have audio, which is really unfortunate, because this is a video from Ghostbusters, and I call it the Spengler. And I don't have the video, but we'll summarize it. But Ghostbusters, everybody. Am I dating myself a little bit? Maybe. But they're in there, and they're like, I forgot to tell you something. Whatever you do, don't cross the streams. Exactly. And he says, well, what's going to happen is going to be the end of the universe. All of our molecules will dissolve into nothingness, and it's really, really bad. And Bill Murray's like, all right, that's really, really bad. We shouldn't do that. This website is actually downloading 2 TED Talks at the same time, every single time you load the web page. And so we've got Shimpei and we've got Elizabeth, and they're both at 64K streams because they screwed up the thing. But if I go and I fix them, we end up with Elizabeth at 320K and Shimpei at 600. They're downloading, but they're downloading them at lower quality than they actually could be, because the 2 players are trying to find the maximum. There's X amount of bandwidth available, and they're trying to balance between the 2 of them so that they can maximize the quality, but they can't do it if they're both downloading at the same time. So we have one there, we have one here. If I just download one video, it's there, right? So we've got, even if somebody scrolled all the way down to the bottom of the page where these 2 videos are and pressed play, one of them would be really low quality and one of them would be really intermediate quality because they downloaded the whole video just when the page loaded. And so if you're downloading a lot of video, if you have a lot of videos on your page, don't download them all at once. Don't cross the streams, as they would say in Ghostbusters. Stream 2 videos at once is going to lower the quality of both of them. You can't have 2 great high quality videos downloading. You're actually impeding the quality of the video that you're serving to your customers. So in conclusion, video files are really, really big. They're the biggest thing you're going to have on your web page. And you should really do a little bit of work to optimize them so that they get delivered properly to your customers. And so some of the best practices I've gone through is resize the videos for the screen. You can change the quality, you can change the bit rate, you can change the dimensions, you can serve a 2x or a 3x or not to mobile, depending on what you want to do. If the video isn't going to be shown, please don't download it, right? Let's not waste our, let's be respectful of our mobile users' data plans. Avoid preload equals auto, preload equals metadata, should be careful. If the video isn't going to play the audio, strip it out and don't duplicate video traffic. Don't download the same thing more than once. When it comes to streaming, you can start at a lower bit rate for faster startup, knowing that it'll be pixelated at the very beginning. If you want better quality, start at that middle bit rate, sort of that Goldilocks approach, right? It'll take a little bit longer, but it will have a higher quality. I didn't get to this one, but I've seen where there are big jumps and rate changes. Sometimes the player switches back and forth between bit rates a lot, and it actually leads to stalls because it's not getting future chunks. It's just stuck between 2 segments, and it starts downloading duplicate content. And then, as I showed in that TED Talk, use the right bit rates in the manifest to optimize the delivery. In this case, they were artificially degrading the quality of their video because they had these really high numbers in the manifest file. And then finally, 1 video at a time, don't cross the streams. And so with that, I'd like to thank everybody for listening, and happy to take any questions.
All right, that's great. Anybody got any questions that they'd like to? Just get this thing turned on. We're good to go.
Hi there. So this is a Spengler question, crossing the streams. I've got a requirement for a series of videos to be in a page, a long scroller.
Right.
What are you recommending? Don't start any of them. Is that enough to keep out of the problem, or is it going to be a problem if they don't start? What should I do?
So that's sort of where you go back to the metadata idea, right? So if it's a small enough video, you can download the first few segments and it's fine. Of each of them, yeah. If for the video equals metadata, it'll download the first little bit of each MP4 if you're using MP4s. In the case of the Spengler question, they were downloading. They had additional videos in addition to the streams. Like this website, they had sort of a carousel of videos, and they were downloading them all at once at the very beginning. I didn't get up to that, but obviously don't do that, right? Like. These video files are really big. There's a university that downloads every single time I load the page. It's over 100 megabytes of data just because it has all these videos that is preloading all of the information. I would just be really careful. I'd audit it. I think all of this sort of depends, right? What you're looking for. If there's a high probability that a lot of those videos are going to be played, get them onto the page. But for some of these examples, like the odds that somebody's going to scroll 14 viewports down to find the video and press play is really low, it's probably not worth doing it. Yeah, of course.
Anyone else? Ooh, we've got a shy crowd tonight, or just no questions. Right. In that case, well, just give. Oh, all right.
All
Okay.
A little bit of video work that I've been back to. I haven't done it for years. So in terms of providing streams then, so hosting video, would you summarize like some of the options? I did have a client about a year ago just wanting to embed more video. Actually, it was kind of in a WordPress site, but it was more like it was subscriber content behind a paywall.
Okay.
And we looked at the kind of video delivery platforms now that you can effectively build yourselves a Netflix in a box, right? Huge amounts of hosting optimization, huge amounts of codec selections and that. So a few little best practices for hosting options rather than just throwing it on my current web server.
Throwing on my current website or just putting them all up on YouTube, right? I mean, that's also another way to do it. It all goes back. Were they streaming, or are they just MP4s, or they're streams?
No, so it's MP4s.
MP4s. I think there's so many different ways we could go with that. I'd be happy to chat with you offline. I mean, I think, obviously you want to have as much of it, as CDNs and all those sorts of things, and get it to the edge of the network as best as you can. And then, really the smaller the video that you can deliver, where it still looks good. I mean, we talk a lot about image optimization. We talk about optimizing the JavaScript and the CSS to make things smaller. And then we see all these web pages that are just like, hey, I made this video with my smartphone, and they just put it on the web page, right? I think there's just doing some of these basic optimizations are going to get you a long way. Yeah, Andrew.
Oh. Hang on, Andrew.
Yeah.
How much of the optimization best practice for recorded video would you say is the same as for live video? And how much is unique to each one?
That's a good question. And I didn't even get to live here because live opens a whole nother complete can of worms. Because obviously with live, you're trying to get things across the network as quickly as possible. So there's a lot of things like, do you lower the segment size? A lot of things like, do you lower the segment size to really small? That gives you a lot of header overhead that can slow things down. And obviously transcoding videos on the fly really fast so you get the different bit rates and things adds a lot of complexity to it. But I think if you're building different bit rates of a stream for different players, I think a lot of that's what I talked about here still holds. You should optimize it as best you can so that it delivers quickly to all the different devices that are out there. Yeah, go ahead.
Another one. It's keeping me fit tonight.
So I'm also curious about sync for live video, and even for recorded video in a sense, I guess. If you've got multiple devices that you want to play the same video at the same time in sync.
Yes.
What do you think is, I mean, like, this is an active problem on the internet, right?
Right.
Because you walk down the street for the World Cup final or whatever, and you hear it's coming out of all the windows, but it's not coming out of all the windows at the same time.
Right.
What do you think is the solution to that ultimately?
I haven't even gotten to that stage yet, right? That's obviously
only look at one screen.
Yeah. Oh, yeah. But you can hear that, right? I mean, I could hear that as I was traveling because I could hear the groans as from the different windows down the street as it was different from different houses, or the cheers, as it were. Obviously, that's the huge unsolved problem. I don't have an answer for that.
With HTTP2, we have in the browser the capability to basically slow down a video stream, or even to reduce it, give it a budget that it doesn't even download anymore. Do you see a future in implementing that in browsers, basically making browsers smarter to not download waste in the case of just videos that are not being used actually?
I think that would be great. I don't.
Okay,
Yeah.
if it's just a bullshit idea, I mean,
If you know, and I think a lot of browsers, I think each browser downloads things differently. So like metadata works differently in the different browsers. They download different amount of content. So yeah, I think that if there's something that we can do from a standards protocol to prevent video that isn't going to be played from being completely downloaded, I think that's a huge advantage.
okay, thanks.
Anyone right at the front?
Thanks. Hi. You were making comparisons to optimizing images for mobile, and obviously when we're talking about images, we'd progressively enhance from a lower res to a higher res. Are there any similar techniques you can do with videos? Obviously we could with streams, but with like raw video tags.
So I guess that, so like if you're changing the dimensions of the video, I mean, that's where things get difficult, right? So when you talk about responsive images where you have different size images for different size screens, you probably can't have 20 different videos, right? Because the sizes are just so much larger. But if you had, I mean, what we're seeing here is most sites don't only have one size image for mobile and for desktop. I mean, 2 or 3 would be a huge improvement. You know, the Major League Baseball one that I showed, if they did those 2 optimizations for those 2 different videos, it would take up the same amount of data as the one video they had, but it would be smaller for both desktop and for mobile, and it would use the same amount of, you know, storage space on their back ends. So just by optimizing the video and then making 2 different sizes by doing the optimizations, you're probably not using that much more server space, but you have 2 optimized videos that would be, 2 is better than 1, I guess. And if you could do 3 or 4, that would be even better. But I obviously there's a cost benefit ratio to all of these different things that you have to investigate as you're doing this.
Any more? No, sounds like it's it. So thank you, Doug. We'll give one more round of applause for Doug for a great talk.